You know the cinematic version of a solar storm. A wave of cosmic energy washes over the Earth, and the smartphone in your pocket starts sparking, stutters for a second, and then permanently dies. The science tells a completely different story. If a massive solar event hits us today, your phone's screen will remain intact, the battery will hold its charge, and the microchips inside will survive without a single scorch mark. But despite surviving physically unscathed, that powerful computer in your hand will suddenly become a completely useless, glowing brick. We are currently sitting at the maximum of solar cycle 25. This means X-class flares, the highest and most intense category of solar eruptions, and severe space weather are our current reality, not a distant sci-fi scenario. A solar storm completely bypasses the physical hardware in your pocket. Instead, it aggressively targets the massive, invisible ecosystem that gives your device its power in the first place. To understand why your phone fails, we have to look away from the device and look at the vast terrestrial network it speaks to. We are talking about thousands of cell towers, thousands of miles of fiber optic cables, and massive data centers consuming megawatts of power. Above all of that sits our most critical and exposed dependency, the global network of orbital satellites, specifically the GNSS. GNSS stands for Global Navigation Satellite System, which is the international constellation of satellites that provides pinpoint positioning and timing data to Earth. A smartphone on its own has very little inherent capability. It is essentially just a highly polished viewing pane that relies entirely on a constant, uninterrupted flow of data from this external infrastructure. Our greatest technological vulnerability lies in our total reliance on this exposed, hyper-connected network. We built a world dependent on absolute precision, and we placed its vital components directly in the firing line of our local star. When space weather turns violent, it happens in 3 stages. First, the solar flare, an intense flash of radiation reaching Earth in 8 minutes. Next, the coronal mass ejection, a massive plasma cloud hurtling at millions of miles per hour. Finally, the geomagnetic storm occurs when that plasma cloud physically slams into Earth's magnetosphere, aggressively distorting our magnetic field lines. We can see exactly what happens without that protection by looking at Mars during the massive solar storm of May 2024. Mars lacks a global magnetic shield. During that event, NASA's Curiosity rover detected a massive spike in radiation, roughly 7,500 times the normal background level, hitting the surface directly. Earth's magnetic shield protects our biology from that deadly radiation. But in the process of absorbing that impact, our upper atmosphere becomes violently agitated, creating a severe threat to our technology. The most visible effect of this atmospheric agitation is highly deceptive. We get beautiful auroras pushing far beyond their usual polar boundaries, painting the sky as far south as Mexico. Behind that visual beauty is a serious unseen danger. The storm severely agitates the ionosphere, a layer of Earth's upper atmosphere filled with charged particles. When this layer is turbulent, it scrambles the incredibly precise radio signals trying to pass through it from orbiting GPS satellites. We saw this play out in real time during that May 2024 event, which was classified as a G5 storm. A G5 is the highest and most extreme classification for a geomagnetic storm. In the American Midwest, agricultural GPS systems lost their accuracy, causing highly automated tractors to literally drift off course during crucial planting seasons. This single disruption to satellite precision risked over $500 million in potential losses for the farming industry. Down on the ground, there is a secondary physical threat. Severe geomagnetic storms induce rogue electrical currents that surge directly into terrestrial high-voltage power grids, pushing transformers far past their design limits. The real danger of a solar storm is quiet. You won't see a fiery explosion. You will experience the silent, cascading failure of the precision systems that feed our devices. We expect the apocalypse to look like a sudden, dramatic blackout, but a solar storm attacks through the gradual degradation of precision. To the person holding a smartphone, this degradation looks like chaos. Digital maps start lying about your location. Network data drops out intermittently. And the fundamental time synchronization that keeps the global financial system and internet servers talking to each other begins to fail. Our hyper-advanced civilization relies on exactness.
We don't need our infrastructure to be physically destroyed to experience a collapse. We merely need those systems to lose their exact timing and precise location data. Without exact GPS, immediate cloud server access, or a perfectly balanced power grid, the smartest piece of technology in your pocket quickly reverts to being an elegant, useless piece of glass. The high activity of solar cycle 25 is not an apocalyptic anomaly. It is simply our star acting exactly like a normal, active star. The intelligence of our modern world is an illusion. We offloaded all the heavy lifting to a fragile, highly exposed network of orbital satellites and terrestrial power grids. Human technology only functions flawlessly when the cosmos allows it to, and a solar storm simply reminds us who is really in control.